Okay guys, we are starting our next unit. So we are entering our Conics unit. We are in unit 14. Day 1. And today we are going to focus on circles, which you all have gone over pretty thoroughly in geometry. So it should be an easy day for you. Let's talk about what makes a circle so special. So we know in a circle, the distance from the center to the rim of the circle is the same length no matter where you go. As long as you're going from the center to the rim, every segment is an equidistance from the center. And we know from geometry that those segments, the segments from the center to the rim, are called radii. And we know in a circle, all radii are congruent. We could actually use the distance formula to derive the equation of a circle. So let's say I gave you a circle with center 0, 0, a point on the circle represented by x, y, and obviously the radius of the circle we will represent with r. So if we're using the distance formula, we know the distance between the center and the point xy. So the distance between the center and xy is going to be found by taking the square root of the difference of the x coordinates squared plus the difference of the y coordinates squared. So let's plug into this distance formula. Well, the distance between the center and the point xy is actually the radius. So instead of d, we're going to substitute in r. And we will call 0, 0 x1, y1. And we will call xy x2, y2. And if we're going to plug into this formula, we're going to have x minus 0, and we'll take that difference and raise it to the second power, and add to that the difference of y minus 0 raised to the second power. So here we have the root of x squared plus y squared. Now let's say we wanted to get rid of the square root. If we wanted to get rid of the square root, what are we going to have to do? We're going to square both sides, and we'll end up getting r squared is equal to x squared plus y squared. And this is actually the equation of a circle that has a center of 0, 0. Now, what's an equation of a circle that's not centered at 0, 0? So let's write this down. Equation of circle in standard form. Equation of circle in standard form is going to be represented by x minus h, so the difference of x and h squared, plus the difference of y and k squared, and that's going to equal r squared. H comma k is going to represent the center of our circle, and r will represent the radius. All right, let's try some practice problems now. Let's write an equation of a circle with center 0, 3, and the radius will equal 7. So when I'm asking for an equation of a circle, I'm asking for an equation in standard form. So we want the difference of x and h squared plus the difference of y and k squared, and we want that to equal r squared. Well, I'm giving you the center and I'm giving you the radius. So we want to recall that the center is going to be represented by h comma k. So this is going to be x minus 0 squared plus y minus 3 squared is going to equal our radius squared, which will be 7 squared. Now I'm going to go through this formula and simplify it just a little bit more. Now in that first parenthesis, we have x minus 0 squared. We don't really need to show that minus 0. It's saying take nothing away. So we're going to simplify that down to x squared plus y minus 3 squared is going to equal 7 squared, which is 49. And this is the equation of our circle in standard form. Hey, let's do another one. So now I want you to write an equation of a circle with center 0, 3 and radius will be, I'm sorry, that's the same problem we just did. Let's backtrack. Not center 0, 3. So with center negative 8, 7 and radius a half. Now I want you to take a minute and just pause this video. I want you to pause this video and try coming up with the equation by yourself. And once you've come up with the equation by yourself, play the video and make sure that you've done it correctly. So we will go through. Now we want an equation of a circle. An equation of a circle in standard form will be represented by the difference of x and h squared plus the difference of y and k squared, and that is going to equal the radius squared. We know negative 8, 7 is going to represent our center. So this is going to be x minus negative 8 squared. And I'm going to leave it like that just for a minute. And let's keep going. Then we're going to have y minus 7 squared. And that will equal a half squared. Now let's focus on that parenthesis that had the x. It said x minus negative 8. Well, we know that double negative will make a positive. That double negative will make a positive. So we're going to have x plus 8 squared. So if the coordinate for the center is negative, we will actually end up with a plus in our standard form of the equation. I'm going to say it again. If the coordinate in our center is negative, we will end up with a plus in our standard equation. So we have x plus 8 squared, and then we're going to have plus y minus 7 squared is going to equal a half squared. Well, what's a half squared? It's a half times a half, which is a fourth. And this is the equation we get in standard form. Okay, before we do the next problem, let's talk a little bit more about the equation of a circle. So we should be pretty good. The difference of x and h squared plus the difference of y and k squared, that's going to equal the radius squared. Now we know h and k represents the center. We know r represents the radius. What do you think x and y represent? It's the same thing x and y represent in a line, in an equation of a line. It's the same thing x and y represents in the equation of a parabola. Take a minute and think about it. What does it represent? It represents all the points that can exist on that circle. So HK is the center, R is the radius, and XY represents all the points that can exist on the circle. So now let's say I give you different information. Now I still want an equation of a circle, but now let's say I tell you the center is negative 3, 5. And the circle passes through the point P, which is 7, negative 3. Now, when we think of an equation of a circle, in order for us to feel that it's complete, we know we need a couple of things. We need a value for H, we need a value for K, and we need a value for R. If we're able to find all of those, then we are able to successfully create an equation of a circle in standard form. Well, luckily for this problem, we have our center. We know our center is our H comma K. So how can we substitute this in? So we'll have the difference of, well, actually the double negative will make it a positive. So the sum of x and 3 squared, the difference of y and 5 squared, but now we still have the r squared. Now we can find r. We can do it one of two ways. We can say, well, I know the point 7, negative 3 can represent x and y. And I can take that x and y and I can substitute it in for x and y in my equation and solve for r. That's going to be the first way we do this. So let's go through that. So we're going to have 7 plus 3 squared. So I just substituted the x coordinate in for x. And then I'll have negative 3. So I'm substituting in the y coordinate. So negative 3 minus 5 squared will equal r squared. Let's simplify what's inside our parentheses. So we're going to have 10 squared, don't lose that plus sign, plus negative 8 squared equals r squared. So we will have 100 plus 64 equals r squared. So we have 164 is equal to r squared. And actually in the equation we want r squared, we do not want r, so we do not have to root both sides. So our equation of our circle with center negative 3, 5 that passes through the point 7, negative 3 will be the equation x plus 3 squared plus the sum of the difference of y and 5 squared equals 164. Hey, there was another way we could have done this. We know the radius of the circle, think about it, we know the radius of a circle is the distance from the center to any point, probably wouldn't be up there, from the center to any point on the rim of the circle. So we could have used the distance formula between the center, negative 3, 5, and the point 7, negative 3. We could have used the distance formula to find our radius and then square it. So that would have been another method. All right, let's move on to another problem. So now this time I'm going to give you the graph and I want you to find the center and the radius. So let's say, let's go over here and copy one of my graphs for us. Okay, so let's say I gave you a graph. And the points on the rim are the points 1, 1, 3, 3, 1, 5, negative 1, 3, and my center point is the point 1, 3. And there's our circle. So now, given this graph, I want you to come up with the equation. Well, we know the equation of a circle, getting very repetitive here, is the difference of the h and k squared plus the difference of y and k squared, and that's all going to equal the radius squared. Okay, well, we know our center, so we had said the center is the point 1, 3. Now, the radius, you can use the distance formula to find the radius, or you could just look at the graph and count, right? The radius is the distance from the center to the rim of the circle. So from our red little dot here to the rim, our horizontal change, we're moving 2 units. So that means our radius is 2 units long. So we know our center is 1, 3, and our radius is 2. So if we just plug that into our formula, we will get this equation. The difference of x and 1 squared plus the difference of y and 3 squared equals 2 squared. Well, we know 2 squared is 4, and here's our equation in standard form. Okay, we have a couple more problems and then we will call it a day. So let's try one that makes us think a little bit more algebraically. So now, once again, I want you to come up with an equation of a circle. But this time, I'm giving you an equation that's not in standard form. So let's say I gave you x squared plus y squared plus 8x minus 6y equals 0. And let's say I asked for you to identify the center and radius. So I gave you this equation. I want you to identify the center and the radius, but I haven't given it to you in standard form. So we have an equation, but it's not the format that we are generally used to seeing for a circle. So what are we going to have to do? Well, I need to put it in the form. We need to put it in the format, the standard format that we are used to seeing. So I'm going to group my x's together. So we're going to have x squared plus 8x. And then I'm going to group my y's together, y squared minus 6y. That's going to equal 0. And guess what we're going to have to do? We are going to have to complete the square. We're going to complete the square for the x's. We're going to complete the squares for the y. So let's go through that pretty quickly. We're going to have half the x coordinate. So half of 8 is 4. 4 squared is 16. So we're going to have x squared plus 8x plus 16. Now remember, to keep our equation balanced, because I added 16 to the left side of this equation, we are going to have to add 16 on the right side of our equation. Now let's complete the square for the y's. Go to your y term. Half of 6 is 3. 3 squared is 9. So I'm going to add 9 in the parenthesis with the y's, but again, to keep our equation balanced, if I add 9 to the left side of my equal sign, I'm going to have to add 9 to the right side of the equal sign. Now, if we go to each of these parentheses, we are going to be able to factor them. X squared plus 8x plus 16, that's the same as saying x plus 4 raised to the second power. So the sum of x and 4 raised to the second power. Y squared minus 6y plus 9, if we factor that, we're going to get the difference of y and 3 raised to the second power, and that will equal 25. Now that we have our equation in standard form, it's pretty easy for us to identify the center, which will be the point not 4, 3, but negative 4, 3. And our radius is not 25, it's the square root of 25, which is 5. Okay, last problem for us today. What number are we up to? I don't even remember number 6, so we are up to number 7. So we're going to have, once again, I want you to identify the center and the radius, and I'm giving you the equation x squared plus y squared equals 4x plus 9. Okay, so what are we going to do? Obviously, this is not the format we wanted in. We cannot say that this is an equation of a circle centered at 0, 0, and the radius is 9 because, I'm sorry, the radius is 3. We cannot say that because of this 4x here. That changes it for us. If we just had x squared plus y squared equals 9, then that would be fairly simple. We'd say, okay, well, our center is 0, 0, our radius is 3, and we'd call it a day. But because we have that addition of 4x on the right side, we know more has to be done. So what are we going to do? We are going to have to subtract that 4x over to put it with the x's. So we're going to have x squared minus 4x. We'll still keep the y squared with them, and that's going to equal 9. I'm going to keep the 9 on the right side. Anytime, any loose number we have, by loose number I mean a number without a variable attached to it, we're going to always keep it on the right side or the opposite side of whatever the variables are on. So I'm going to group my x's together, and I'm going to complete my square for the x's. I don't need to complete my square for the y's because we can just represent this as y minus 0 squared. So it's already complete. Now, when working with the x's, I'm going to go ahead. I have x squared minus 4x. Remember, we're going to take half our x coefficient. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 to the x's. And now to keep my equation balanced, I'm going to add 4 to the right side. So I'll add 4 to the 9. I'm going to factor my first parenthesis. And we're going to have x minus 2 squared plus, you can write y minus 0 squared if it makes you feel better, and that's going to equal 13. All right, so what is our center? Our center is the point 2, 0, and our radius is not 13. Our radius is the root of 13. Now, I didn't ask you to graph this, but let's say I did ask you to graph this. Graphing root 13, we're going to have to sort of guesstimate where root 13 would be. How long is root 13? So think about it. We're going to pick the two closest perfect squares to 13. So the two closest ones are root 9, and then on the higher end, root 16. So the square root of 9 is 3. The square root of 16 is 4. That means we are going to be somewhere between 3 and 4, closer to 4, slightly closer to 4. So I would set a guesstimate root 13 to be about 3.6. And that's how you would graph it, with a radius of 3.6 and a center of 2, 0. All right, guys, so we are finished for today. I will list your homework on Google Classroom, and we will meet again tomorrow. Have a great day.